Okay, we are in lesson 2.4. Students just started the warm-up. Number 1, write an equation in slope-intercept form that has a slope of -3/8 and a y-intercept of 7. Okay, really quick. Who can tell me the slope-intercept form of a line? Y equals mx plus b. Beautiful. Thank you. Slope, we plug in for what variable? You can shout out. M. So now our slope is -3/8 x plus y-intercept, we plug in for what letter? B. Good. Wow, you're given all the information we needed to write that equation in slope-intercept form. Slope-intercept form, we needed slope, y-intercept, that was given to us. All right, number 2, write an equation in slope-intercept form that has a slope of 4 and passes through 0, -5. All right. Raise your hand for this one. Anyone know something special about this point? Connor?
That's the y-intercept since the x-coordinate is 0.
Oh, I hope the microphone picked that up. I could have said that more beautiful. He said it's a y-intercept because the x-coordinate is 0. Good, that's really my y-intercept. It didn't flat out tell me what my y-intercept is. It was a little bit in disguise, but we talked about intercepts. Good catch. So same idea here. We could just plug 4 in for m, and for our slope, x plus b. So you could do plus -5 or -5. Okay. Good deal. Now we're going to get to ones where we're maybe not given the y-intercept, or maybe we're not even given the slope and how we can write equations. But this whole lesson is focused on writing linear equations. So no graphing. We're just writing equations, given different information, sometimes a word problem. Okay, so here's our goals for this lesson. Write an equation of a line given the slope and a point on the line. We just did an example like that, but the point was always the y-intercept. It's not always going to be that case. And then we'll also write equations of lines that are parallel or perpendicular to certain lines. You've done this before in Algebra 1. Okay. It'll feel familiar. So, here are our 2 forms of our line that we're going to focus on today. So we actually talked about standard form in a recent lesson. So our other 2 forms of our line are slope-intercept, which is what we're most familiar with, and that's the one City said was our y equals mx plus b, where m is the slope, and b is the y-intercept. Like this point on our line, 0, b, m. We talked a lot about slope last lesson. That's our slope. Okay. Now, the only time we can jump right to slope-intercept form is if we're given the slope and given the y-intercept, like those 2 we just did in the warm-up. All right? If we're not flat out told what our y-intercept is, then we're going to have to use this other form of a line called point-slope form. Okay, have you guys seen this before in Algebra 1? The y minus y1 equals mx minus x1?
Yeah.
Yeah, okay, great. Thanks, Connor.
You're welcome.
Okay, write this one down. So there's a couple different ways you can actually do these problems. Some of you might have been taught to do it this way, or maybe you've been taught to use y equals mx plus b form and like plug in the point for x and y and like solve for your b. I'm a big fan of this because we use this a lot in like calculus. Okay, so if you ever get to that point in your math career where you have to take calculus, you have to know this one. So I like to start people off right away on the right track and using this point slope form. All right, so this is called point slope form, and we use this. M still represents my slope. We know the slope, and we know some random point on our line. That's not the y-intercept. This is any old point, and this works for any point on your line. Okay, x1 and y1, you could read that as x sub 1 as a little subscript, or y sub 1, but we leave the x and the y in the equation, just like what we did in slope-intercept form, where we left y equals We left the x and plugged in the slope, plug in the y-intercept. Here, we're just going to plug in the slope and plug in a point. Okay? Now, if they ask us to write it in slope-intercept form, we can just do some algebra here, distribute, and solve for y. Okay, you guys ready to try one?
Sure.
I don't know if you're ready today.
Yeah.
Is it because I'm out of candy? Oh, no, there's still some candy in there. Okay, let's practice from a graph first. So, write an equation in slope-intercept form for each graph. Okay, the first thing I do when I give a line is I like to find my slope. Okay, you guys go ahead, figure out the slope for the line in number 1. This is what we practiced last lesson. Find a slope. Should have gotten positive 2 over 3. Okay, the next thing I ask myself, can I tell what my y-intercept is by looking at this line? Does it definitely cross clearly on the y-axis? Yes, it does, at 0, 6. So my y-intercept is 6. Beautiful. So to write this in slope-intercept form, y equals mx plus b. We just plug in positive 2/3 for our slope, positive 6 for our y-intercept. Okay. Also, this is picky, but I was really picky with this with my Algebra 1 students when I taught Algebra 1 last year. Make sure your x is like not in your denominator like that, because that's actually not a linear function, right? You can't divide by x. So make sure your x is very clearly like written big next to it as 2/3, like times x, not 2 divided by 3x. Okay, questions? Number 2. Go ahead, folks. Calculate the slope. Start with the slope. Okay, 2 points were labeled here for me. How nice. I got negative, make sure you had negative, 1 over 3. And the next thing I ask myself is, can I tell what my y-intercept is by looking at it? No. Could I guess?
Yeah.
Well, we shouldn't. Well, we could, I guess, ideally. We shouldn't, though. So here is our first example where you can't just jump to slope-intercept form, and I have to do my point-slope form. So I don't know the y-intercept, but I do know a point. For example, and you can use any point on the line, but might as well use one that's clearly labeled for us. That point right there is 2, 3. Okay? So what we're going to do is we're going to use our point-slope form, which, let me just rewrite it for you quick. You don't have to rewrite it, but y minus y1 equals m parentheses x minus x1. Okay, so we leave the x and y. We still plug in our slope for m, so negative 1/3 would go in for m on the right-hand side of my equation outside the parentheses. And then this x1, y1 represents any point on your line. So the x-coordinate of the point that I picked is 2, and the y-coordinate of the point that I picked is 3. Now careful, make sure you plug it into your equation correctly. You want to put the y-coordinate by the y, the x-coordinate by the x. Okay, so I have to use this point-slope form. Now the directions say, write this equation in slope-intercept form. Is it my equation right now in slope-intercept form?
Yes.
Is it solved for y? Is it y equals mx plus b?
No.
No. Okay? So you're just going to have to solve this for y. No worries, it's not hard. It's literally 2 steps. Distribute. 2 steps. That's negative 1/3 x. Negative 1/3 times negative 2 is positive 2/3. And then the only other thing you'd have to do is add over that 3. Okay, think of 3 as 9/3. That helps. 9/3 plus 2/3, we get 11/3. Now, what I always encourage my students to do is get 11/3 as a decimal. So anybody know what that would be as like a decimal? 3.6 repeating, right? Yes, 3.6 repeating. So 3 2/3, 3.6. Does my y-intercept look like it's about 3.6? 1, 2, yeah, it does. Okay? So double check once you do point slope form and see if you get the right answer. Out of curiosity, were you taught in Algebra 1 to do it this way, or were you taught to do this and plug in the slope and plug in the coordinate and like solve for b?
He was
We did both? Okay, great. I ultimately, guys, you can use either method. I don't want to say I don't care, because of course I care about you. It doesn't matter to me which you use. I just prefer this because I know what road lies ahead for you in the math world. Okay. But if the other way makes more sense to you, and you don't get this, or you don't like to memorize forms of equation, that's fine. If you know, you'll get the same answer either way, if you don't have point slope form memorized. All right. Ooh, I said we weren't graphing. I lied. These are really quick. Just a couple special lines. We looked at these actually with the slope dude video. So just know, let's say I have a slope of 0 and a y-intercept of -2. So you have a slope of 0 and a y-intercept of -2. If I were to simplify this a little bit, 0 times x is just 0. 0 minus 2, I end up getting y equals -2. All right, you guys, show me with your arms, what type of line would that be? This way or this way?
What's Nick doing?
Horizontal, right? That's how I put you through that. No, I'm just kidding. -2 on our y-axis. And it'd be a horizontal line, right? Horizontal lines have slopes of 0. That's when slope dude was like, this is 0, fun. Okay, so just be on the lookout for that. If there's no x coordinate, or sorry, not x coordinate, but no like x in your equation, that means it's a horizontal line. We might be also given an equation like this. And you're like, is this even linear? And it is. If we solved this for x, we divide both sides by 3. We get x equals 3. And we know that that is a vertical line passing through 3 on my x-axis. Okay, so be on the lookout for some special lines. This would be a vertical line if you only have x's. And what I always tell my students to remember that too, horizontal, only have y's, is that if you go to your y-axis and you find -2, if you only have y's, it can only cross the y-axis. Okay, so that'd be a horizontal line. If it only has x's, it can only cross the x-axis. So there's no way I could draw like a line, like if I did horizontal for that one, it'd pass through my other axis. Would a vertical lines have a slope of? No?
Undefined.
Undefined. Remember when he called out the slope? James, I know you went home and watched that video again. Don't lie. I know you showed it to your
I
brothers.
saw that.
I should have just said.
Probably a good thing.
What do you mean?
Oh, it's just
Such a good story.
The art. Slope dude art. Positive.
Okay. Let's take a look at something like this. Write an equation in slope-intercept form for the line that has a slope of -3/5 and passes through 5, -2. Okay, so they gave me the slope. It's obviously my m. Now the point. Every day this test is my patience. Did the point they give me, is that my y-intercept?
No.
No, because the x-coordinate is at 0. So I'm going to have to do point slope form. So that's my y minus y1 equals m x minus x1. You don't have to write this out every time, but a good way to memorize things is to keep repeatedly writing it. And it's really easy then when you write your work underneath to see what you're plugging in where. So for m, I'm plugging in -3/5. Okay, remember I told you got to keep the x's and y's. And then we plug in for x sub 1 and y sub 1. All right, what would my x sub 1 be in this case? You can shout it out. What would I plug in for x sub 1? 5. Thank you. 5. What would I plug in for y sub 1?
No, 2 because 2
Yep. So y minus -2, you could just change that to +2. Okay.
Still plug in for -2.
Yeah.
All right, now we're going to put this in slope-intercept form. Here's good practicing distributing. Good practice with a few more fractions on here for you guys. This one actually turns out pretty nice, though. -3/5 x, because -3/5 times 5, those 5s we cancel out, we get +3, and then you'd subtract over 2, so you get +1. All right, so without graphing this, what's the y-intercept? 1. Good. +1. Okay, you guys try this one. What does an equation in slope-intercept form that has a slope of 2/3 and passes through -3, -1? You've got 1 minute to try it. Okay, so I changed y +1 and x +3 minus a negative. Oh, dang it. This one worked out nicely too with the fractions. Don't worry, I'll get you some harder ones soon. 2/3 x plus 2, subtract over 1. All right, raise your hand if you got that for an answer. Oh, everybody except Nick.
Oh, I got it right. I was zoning out for a second.
Good job, team.
What?
What would the y-intercept of this line be?
1.
1.
1.
Yep.
Yeah, Mary.
Thanks.
Okay. Let's step it up a notch. Level 3. Write an equation of the line that passes through 2, -3 and -3, 7. Any idea what we could do here? Ooh, yeah.
Put the numbers in slope, like the slope form, you're gonna do y2 minus y1 over x2 minus x1.
Good job. Let's calculate the slope. It only takes 2 points to calculate the slope. You said that beautifully, Cindy. Hopefully the microphone picked that up too. She said, let's use the slope formula. Use x1, y1, x2, y2. This is what you practice on your homework. So y2, 7 minus y1, -3, all over x2, -3 minus x1. So I have to use the slope formula in this case because it didn't come out and tell me what my slope is. But we know how to do this. We get 10 over -5, which reduces to -2. You can do it -2 over 1 if you want to. However, we're not graphing here. We're just writing the equations.
Huh?
Wait, no, I'm wrong.
You're good?
Yeah.
Okay. I didn't even hear what you said. Okay. So if you want to write it as -2 over 1. Oh my gosh. -2 over 1 you can. But we're not graphing. We're just writing the equation. So -2 is probably easier to work with here. Slope is -2. Okay, that's good to know.
Now we have to do the line.
Now we have to do the point slope form. Good job, Kayla. Neither of these are my y-intercept, right? Neither of these points have an x-coordinate of 0, so we're gonna have to do point slope form. Y minus y1 equals m, x minus x1. Kayla, which point do you want to use? I'll let you choose. The first one?
Yeah.
2, -3. That's what I picked too. It doesn't matter. You can use either point, right? Okay. So 2, look, I already have it labeled for me, x1 and y1. 2, -3 would turn into +3. And slope is -2. Okay. Write this in slope-intercept form. Make sure -2 times -2, we get +4. I know this seems easy, but I'm not kidding you. A lot of you guys made mistakes like that on your test. Distributing negatives to negatives, okay? Dang, why are we getting y-intercepts of 1 on all of these?
Because your notes are just one off.
Yes.
Indeed.
Well, that streak is ruined on the next one.
Oh.
Dang.
That, yeah, that's
Are you
what I was
breathing?
saying.
You get a fraction.
Yes, I know.
Okay. Makes sense? So when you're given 2 points, a little bit more work, have to calculate slope. Then we can go from there and use our point slope form. Unless we are given the y-intercept. If this said like 0, -3, we could just do y equals -2x plus 3. However, that's usually not the case. But be on the lookout for that. Work smarter, not harder, am I right? All right. You guys go ahead and do this one. Now let's do it in pieces because I don't want you to do the whole thing and then realize you did your slope wrong. So everybody, I'll give you 30 seconds. Calculate the slope. Starting. I'll get my stopwatch. Now, 30 seconds. Five, 4, 3, 2, 1. All right, what did we get?
2/3.
2/3. I'm hearing from one person. 2/3. What'd you get, Kayla?
I got 2/3 as well.
I got 2/3.
I got 2/3.
2/3.
Okay, well,
Be nice. Be nice. I also got 2/3. Okay. Now go ahead and write the equation. I'll give you another 30 seconds. Time. Ooh, I stopped it right at 30 seconds on the demo. All right. I like to pick points that are positive, so I picked that first one, plug in. Did anybody pick the other one just out of curiosity?
I did.
Okay, let's see if you get the same answer. It don't matter. You can use either point. It's a fun thing about lines. All right, let's check our fraction work here, people. All right, in my case, when I added over the 5, I thought of that as 15/3. You should have gotten a y-intercept of 11/3. Okay, if you didn't get that, check your math. Check your fraction action. That's about as tough as they get is when we have to calculate our own slope. Now, the only other types of problems you might see is where they just basically give you your slope in disguise, is how I like to call it. They'll tell you, hey, your line is parallel to this line, but it passes through this point. Okay, kind of remember these from Algebra 1. Or your line is perpendicular to this line and passes through this point. Now let's talk about parallel lines. We know what parallel lines look like. I gave you a little picture here. Those are lines that never intersect, right? What do we know about their slopes?
They
You can shout out.
They are the same.
They're the same, right? They're always going in the same direction with the same level of steepness, because that'd be the only way that they would never cross each other, is if they're going at that same rate of change. Rate of change means slope. Okay? So here's an example. These both have a slope of 2. Okay, and you can see these are parallel lines. So the slope of the first line is the same as the slope of the second line for parallel lines. Slope of the first line is the same as the slope of the second line if this is line 1 and line 2. Perpendicular lines. Ooh, good throwback to geometry. We're talking about perpendicular lines right now. Perpendicular lines are lines that cross at what degree angle? 90. Good. Yep, they form a right angle. I don't love how the book phrases this. It says, if and only if the product of the slopes is -1. Does anybody else kind of remember the relationship of the slopes of perpendicular lines? What'd you say? Okay, add to that.
The perpendicular slope to the one line is the negative reciprocal of it.
The opposite reciprocal. Good. Yep. So they're reciprocals of each other and they're opposite, meaning one's positive, one's negative. They're going in opposite directions. Okay? So opposite reciprocal slopes. Good job, guys. So the slope of 1, we're going to have to be opposite and the reciprocal. In this example, my slope is 3/1. So the opposite would be negative. The reciprocal would be 1/3. So this slope is -1/3. Opposite reciprocals of each other. It has to be both. Good. So technically, slopes of 0 and slopes of 0 and slopes of undefined are opposite reciprocals of each other, right? They form a 90-degree angle. Those are perpendicular lines, vertical and horizontal lines. Okay. So this example says, write an equation in slope-intercept form for the line that passes through 3, 7 and is parallel to the line whose equation is this. So what they're stating here is parallel to the line -3x plus 4y equals -20. They're really telling you what the slope is. They don't say, hey, the slope is 7. We have to do a little bit of math here to figure it out. How can I figure out what the slope of this line is? Solve for y. Put it in slope-intercept form, right? Let's do that. Divide by 4. Okay. So I took that line they gave me. I put it in slope-intercept form. What's the slope of this line? 3/4. So if our line is parallel to this line, parallel lines have the same slope, our slope is going to be 3/4. That's the only information you're using from that line, folks, is the slope. They also give me a point that it passes through. Is that point my y-intercept? No, of course not. They're going to make me do point slope form, right? So y, I'm just going to go ahead and plug it in right away. Y minus y1 is 7 equals m. Our slope is 3/4. That's what I took from this information. X minus 3. 3 is the exponent of the given point. Okay. Go ahead, put this in slope-intercept form. 3/4 times 3/1 is 9/4. -9/4 in this case. Add over 7. Plus 7. You can think of as 28/4. So 28 minus 9 would be 19/4. Okay, so a lot of the times people like to use the same y-intercept. The only thing you're taking from that statement that it's parallel to that line is the slope. That's your slope in disguise. They're telling you what the slope is. We didn't have to do any slope formula to calculate it. We just had to do a little bit of reorganizing the equation to figure out what the slope was. Okay, similar problem here in number 2, but this time they want me to write an equation in slope-intercept form for the line that passes through 3, -2, so I have a new point here, and it's perpendicular to the line whose equation is 5x plus y equals 1. What's the slope of this line? 1. Ooh, I like this. We don't know right now by looking at it, but I know some of you are thinking ahead. Putting this in slope-intercept form, I'm going to have to move over the 5x. Now let me ask this question again. What's the slope of this line? Y equals mx plus b. The slope is the number in front of x. -5 is the slope here. All right. Perpendicular means we have to do the opposite, so positive. Reciprocal, what's the reciprocal of 5? 1/5. So the slope of our line is going to be positive 1/5. Okay, everybody with me? Then again, we're given a point. Not the y-intercept, of course. So point slope form. All right, 1/5 is the slope. Y minus y1 is -2, so minus -2 is +2. X minus x1 is 3. And then we can go ahead and put this in slope-intercept form by solving for y. Okay. Subtract over 2. So you can write that in your work too if that helps you. Subtracting 2, you can think of that as subtracting 10/5 to -3/5, so -13/5. They almost always leave everything in improper fractions. Okay. We're going to stop there. We'll save the word problems for tomorrow. Does anyone have questions so far? Okay, this is the day 1 video for lesson 2.4. I'm going to stop my recording. Thanks for watching.
Those I see on YouTube get millions of views.